REST is defined by 6 constraints, one of which is optional. You should see these constraints as design decisions. Each of those can have both positive and negative impacts. So, for these constraints, the benefits are considered to outweigh the disadvantages. We're gonna have a look at all of these, but in a practical way. We'll use the fully finished demo application to show how exactly these constraints translate to real-life use cases where applicable. The first constraint is the uniform interface constraint. It states that the API and the API consumers share one single technical interface. As we are typically working with the HTTP protocol, this interface should be seen as a combination of resource URIs, i.e., where can we find the resources, HTTP methods, in other words, how can we interact with them, like get, post, etc., and HTTP media types, like application JSON or application XML. Those media types are reflected in request and response bodies. Let's have a look at the small demo. The application is up and running, and we're in Postman. Let's select the request, say want to get the courses for an author. You can see the resource URI, starting with the scheme, host, and port, and followed by API/authors/ the ID of the author / courses. You can also see the method, get. There's other methods available. We will look into quite a few of these during the course. Lastly, you can see the payload, which is described by the media type. You can find that on the body tab, but for the GET request there is no payload. However, we can already use a media type. We can set the accept header to whatever we want to accept in the response, say application JSON. This states that we, the consumer, want the payload in the response back in JSON format. Let's send this, and there we go. We get back a 200 OK with some courses in the response body. If we look at the response headers, we see that it has a content type header with value application JSON. That's what we requested, and like that, the consumer can know how to parse this content. Let's change this a bit. Let's say we want to create a new author. For that, we can post to API/authors. This time, we do have a request body. The request body contains the author we want to create in JSON format. That request body is the payload. We signify the format of it with the content type header, just as was the case with the response message from the previous request. Like this, the API knows how to parse the content by looking at that header. Let's send this, and there we go. A new author has been created. Also, notice that it returns a different status code. We get back a 201 created. Also, next to the fields of the created author, we also see a links field containing some links that appear to tell us what we can do next. More on that in a minute. All of these, HTTP, JSON, are standards, by the way. And this makes this a good fit for cross-platform development. JSON, for example, is pretty lightweight and can easily be parsed. And using HTTP means there's broad support for this style across platforms. All that is needed to consume an API like this is a client that supports HTTP methods and can parse JSON. By describing this uniform interface contract, the uniform interface constraint decouples the architecture, which in turn enables each part to evolve independently. We're going to design it for our API at the start of the next module. This constraint has 4 sub-constraints. The first sub-constraint is identification of resources. Individual resources are identified in requests by using URIs. So that's the URI we already saw in our demo requests. but the resources themselves are conceptually separate from the representations that are returned to the client. In our demos, we will work with authors and courses. An author resource could be found at API/authors/the author ID, but that resource is conceptually different from the representation of that resource that's returned in the response. For example, JSON. But XML or custom or proprietary formats are possible as well. So we can have different representations for the same resource. We already returned the courses of an author by setting the accepted to application JSON. Let's change this to application XML and send the request again. This time, we get back the same list in XML format. So that's two different representations for the same resource. We can take this a bit further. Let's try getting an author in JSON format. What we see here is that we get back name and age fields. However, if we look back at the request we sent when creating an author, we can see that instead of a name, we inputted a first name and a last name, and instead of an age, we inputted a date of birth. In our case, we don't have a name field in our database, but a first name and a last name field, and we don't have an age, but a date of birth field. What this means is that the server does not send an entity from its database back, or possibly a combination of fields from multiple additional databases and services. That's because our author resource doesn't necessarily map to an author in a database. Instead, it sends the data in a specific data format, but it can also change the fields that it sent to better fit the consumers of the API. So both at level of the data format and at level of what is sent back, so the data type, representations are different from the server's internal representation, but it is the same resource. There's also a few best practices on how to design these resource URIs. We're covering that in the next module as well. Let's continue with the second subconstraint. The second subconstraint is the manipulation of resources through representations subconstraint. What that means is that when a client holds a representation of a resource, including any possible metadata, it must have enough information to modify or delete the resource on the server, provided it has permission to do so. To continue with our example, the representation of an author and its metadata in the response message must be enough to successfully update or delete that author. But what does that mean? Well, if the API supports deleting the resource, the response could include, for example, the URI to the author resource, because that is what's required for deleting it. We're again looking at our request to get an author. In the response, the ID of the resource is included, meaning that the consumer can construct the URI to that resource to delete or update it. This is a relatively often used implementation of this subconstraint, but you could argue that it's not completely correct, as the real resource identifier is the URI and not just the ID. There's various ways to support this subconstraint. Another way would be using metadata, for example by requesting links related to the resource, which would then contain the URI, often via a self-link. Our API supports that. Let's send that request again, but this time using application/vnd.marvin.hateOS plus JSON as accept header value. And there we go. This time we get back some metadata, including a link to the resource itself. That, by the way, is also what we got back in the response when we created an author. Don't worry if it isn't clear yet what this vnd.marvin.hateOS plus JSON media type means. That's already pretty advanced stuff. It's coming up in the second half of the course. The third subconstraint is the self-descriptive message constraint. This states that each message must include enough information to describe how to process it. When a consumer requests data from an API, we send a request message. When it gets back data, that's a response message. That message has headers and a body. If the request body contains a JSON representation of a resource, an author in this case, the message must specify that fact in its headers by including the media type, application JSON for example, as a content type header value. Like that, the correct parser can be invoked to process the request body, and it can be serialized into the correct class. Same goes for the other way around. We know about this one. We've already seen these accept and content type headers. Mind you, application JSON is a simple example. Media types actually play a very important role in REST, and that goes way beyond application JSON. Again, something interesting to learn in the second half of the course. HateOS is the fourth subconstraint. It means hypermedia as the engine of application state. This is the one that a lot of RESTful systems fail to implement.